All right, we are going to be solving one-step inequalities now. This is going to be very similar to what we did with equations, except for now it is an inequality. So the first thing we're going to do is let's just go over the steps again to make sure we're all clear on what to do. Step number one, we're going to simplify if possible. This might include later on things like distributive property, collecting like terms, those types of things. We're still going to draw the upside down T through the inequality symbol that separates our sides from the left to the right. Step number three, just like with equations, we are going to isolate the variable by using the inverse operations. Remember the inverse operations, if my problem has addition in it, we're going to subtract. If my problem has subtraction, we're going to add. If it has multiplication, we're going to divide. If it has division, we're going to multiply. Those are our inverse operations. They undo each other. Now, there is a special rule that comes into play with inequalities. And that is, if you multiply or divide each side by a negative number, then you must flip the inequality symbol. Okay, so I'll show you a couple examples using that. But just, if you multiply or divide each side, so both sides, by a negative number, then you must flip the inequality symbol. Number four, then you're going to graph your solution on a number line. All right, so here we go. Let's solve these. So we're going to start with this first one. It says x plus 3 is less than 4, negative 4. So I can't simplify anything, so I draw my upside down t. I'm adding 3, so to undo that, I minus 3 from both sides. That's going to get me x less than negative 4 minus 3 is negative 7. Okay, so now I come down to graph it. So I'm going to go negative 7, 0, and 7. At negative 7, I'm going to be an open circle because I cannot equal negative 7. And x is less than that, so it would be to the left. Now, if you want to check it, here's how you would check it. If you pick something from your shaded region and plug it in, it should make it true. If you pick something from the unshaded region and plug it in, it will make it false. So, for example, if I pick positive 7, 7 plus 3 is 10. 10 is not less than negative 4, and that made it false over here. If I pick, let's say, negative 10, negative 10 plus 3 is negative 7. Negative 7 is less than negative 4, and that made it true. So that gives me an idea that we're on the right track. Okay, now let's move on to this second one here. Now, just like before, fractions and decimals are fair game. We're not doing anything different here. We're just doing the fraction and decimal piece. There's nothing I can simplify here. So I'm going to bring down my upside down t. Now I'm subtracting 1.7. So to undo that, my inverse would be to add 1.7. So that's going to give me x greater than or equal to 5 plus 7 is 12. Carry the 1, 2, 3, 4. Bring down our decimal point. So 4.2. So to write that in, I'm going to go negative 4.2. 0, and positive 4.2. So now when I come in to graph it, I look at 4.2. I'm a closed circle at 4.2. And it says x is greater than or equal, so I'm closed, but it's also greater than, which would mean I would shade to the right. And that's how we do the addition subtraction ones. Now let's go on. We're going to spend a little more time on the multiplying and dividing ones. So we start here on this first one. It says negative 2x is greater than 12. So I start off, draw my upside down t. Now, it's negative 2 times x. So to undo that, I'm going to divide by negative 2. That's going to get me x. Now, here's where we have to be very careful here. So remember, the rule said if I multiply or divide both sides by a negative, it flips the inequality symbol. So instead of greater than, now it's going to be a less than symbol. 12 divided by a negative 2 is a negative 6. So now I come down here, I've got negative 6, 0, and 6. At negative 6, I would be an open circle, and I would shade to the left. Okay, let's try this next one. So on this one, I draw my upside down t, nothing I can simplify. So I'm multiplying by 3, so to undo that, I divide by 3. Now, when you look at this, you might think to yourself, oh, wait a minute, I should switch it. But stop and think. Did I multiply or divide both sides by a negative? And that answer is no. So we're not going to flip the inequality symbol here. Negative 9 divided by 3 is a negative 3. So when I come down, I have negative 3, 0, and 3. X is less than or equal to, so I'm going to do a closed-in dot. And I'm less than, so I'm going to shade to the left. So notice the difference between those two problems. Okay, let's try a couple division problems. So we're going to start here on the left. I'm going to draw my upside down T. So now I have X divided by 3. So to undo that, my inverse would be 2 times 3. So that gets rid of that, X. Now, once again, I look, am I multiplying both sides by a negative? And the answer would be no. So that means my inequality symbol stays the same. Negative 6 times 3 gives me negative 18. So now I come down, negative 18, 0, and 18. I'm going to be an open circle. X is less than that, so it would shade to the left. On this last one, I'm going to come down. I look for my X. I'm dividing it by negative 4, so to undo that, I multiply by a negative 4. That's going to get me X. Now, when we look at that, here's where we check again. We're multiplying both sides by a negative, so that means that inequality symbol is going to flip, and that would get me 11 times negative 4 is negative 44. So now I come down, I put in my values, and it's X is less than or equal, negative 44 is less than or equal to X. So remember, this is where we kind of think it through. If negative 44 is smaller or equal to X, then X must be greater than or equal to negative 44. So that means we would shade to the right-hand side. And that's how we solve one-step inequalities.